Hello, here is a presentation of my CS-445 databases project. The intent of this project is to dynamically graph data from a DevOps survey. So some quick background on that. Some number of years ago, I ran a survey over 9 quarters at a company I worked at. I collected data about the health of software delivery at our company, how people felt about that. The way this survey worked, there were 6 constructs. Each construct was a collection of related questions. So, for example, this is the engineering culture construct. Every question is required. Everything is on a Likert scale between strongly agree to strongly disagree. What I did with this data is I collected it, collated it in an Excel spreadsheet, and I would do trend analysis on this data over time to try and determine the health of various aspects of our delivery lifecycle. What I've done for this project is I've taken that data and I've anonymized it so that you don't know anything about the environment I collected it in, and I've used that as grist for this graph machine that I've built in Python Flask, and I'll show you how that works. So first off, I have blank Nginx set up here. If I load this web page, you'll see a convenient 502 bad gateway. That just means that my software isn't running. So let's fix that real quick. Let's turn off Chrome. We're going to look at the bottom left window in Tmux over here. And what I'm going to do is initialize our database using a SQL statement. See that on the right. I'm going to talk about that a little bit more, but for now we're just going to run it. I'm not in the right folder. We want to be here. Yes. Cool. Initialized database. That means it ran my SQL. It ran my SQL statements. Next, I want to take a look. Let's make sure that my instance doesn't have any CSV files uploaded already. Uploads, nothing there. Okay, we're good to go. Now I need to start up my application. I'm going to start up my Python application with a WSGI wrapper. I'm using something called Waitress. What WSGI does is it manages the Python process and provides an interface to Nginx. Nginx is the web server. Okay, that's in my history. Waitress serve called DevOps survey. I need to be in the right path. Oops. Yeah, it looks like it started up okay. All right, I'm going to leave that running in the background. I have that running in screen here, so it'll continue running in the background. And let's set up, let's tail some logs. Let's push this off screen. Now, if that worked the way I expect, if we turn on Chrome again, we should be able to load my web page. Let's try it. Cool. All right, so what we see is the landing page for my app. We're going to register a user. I'm Joe. My password is PASSWORD. This is kind of neat. Sometimes Chrome tells me it's a bad password. Let's see if it does that. So I'm trying to log in with that password I created. Change your password. It's an awful password. Okay. All right, now the way this app works, it's fairly simple flow. We have CSVs that are generated by this DevOps survey. At the completion of the survey, I hit a button that says export CSV, and then the CSVs are in, the CSVs that it exports with the sanitized stuff that I've done to them are in my GitHub repo. But we can upload those. This is the same data that exists in my GitHub repo. Let's just pick one of these, Q1 2020. Let's say that's for Q1. It's 2020. Upload it. Cool, it looks like it uploaded. Let's upload 2 more. I'm gonna grab Q4 2019. That was the first instance of the survey. Q4 2019. And let's grab Q4 2021. That was the last one. Cool. So we've got 3 instances of that survey uploaded. And I'm curious to see what some of that data looks like. Let's look at the first instance. All right, so I didn't build a lot of graphs for this. There were some time constraints, but matplotlib it's really extensive in what it can do, and there are a lot of neat things that I might do with this in the future, but for now, all we get is bar graphs. And what we're seeing are the average scores for all of the respondents during the specific instance of the survey that was run. So I think there were something like 40 respondents for Q4 2019. And everybody answered each of these questions on that 5-point Likert scale. And I've added some arbitrary thresholds that show us arbitrary thresholds for coloring these bars for good, okay, bad sort of things. So when I first ran this survey, you could kind of see that we had some problems in this middle space. That's where I focused a lot of the effort in SDLC improvements at this company. Let's take a look at the last instance I ran and see if it looks any better. Cool. Looks like we improved quite a bit on this cultural construct, the collection of questions related to engineering culture, and then that middle space. These were software delivery constructs. Okay, so that's basically the app. Let me show you how it works. Let's turn off Chrome. It's fairly straightforward. First off, we have SQL schema data that we're going to import into the app. We have a users table. This manages the login that I showed you. We have survey instances. There's exactly 1 survey instance for each year and quarter pairing. Each survey instance has created at timestamp, so we know when it was uploaded into the system. We have an instance name. The software will just set the instance name to match the CSV file that we uploaded. Every survey instance has a quarter and a year, and then we use a multi-key primary key for the quarter and year for those instances. Okay, next I talked a little bit about the constructs. The constructs are collections of related questions. The idea is that questions within that construct track together. So there's a cultural construct, for instance. We expect that the overall mood within the organization about the culture it's going to all center around the same sort of midpoint. I don't want to get into the psychometrics of the survey a lot, but every construct has questions. Okay, let's see. Next, we want to look at the instances of questions, or excuse me, the static data for our constructs. So lines 27 through 32 here. We're inserting some static data that says, here are the constructs that are associated with our survey. The application doesn't do this dynamically. This is all done by inserting SQL. Next, we have questions. Same sort of thing with questions. All this data is going to be statically inserted by the SQL command so that we can change it over time, but it's not dynamic with the Python app. So every question has a primary key, auto increment. It has a name. The name is what you're seeing in the graphs. It's just a unique way to identify that question and have an idea about which heading it was associated with in the CSV file. We have a construct ID associated with each question. So each question has a foreign key constraint so that it has to map back to exactly one construct. So after we set up that table with those constraints, we insert each of these questions. Each question has all of those values and is associated with a construct. Let's see, they kind of scrolled off the end here. Okay, yeah, you can see the construct associations here. So the artifact management works question. Does artifact management work? Yes, and that's associated with the dev systems construct. Okay, let's take a look at instances of the survey. So every data point that we might collect is going to have a collection of questions. Every respondent of the survey has to answer every question, and that ends up forming a bunch of Likert scale responses. Each of those responses, each of those sets of questions are constrained. We check them so that they have these values 1, 2, 3, 4, 5 for each case. And then for each one, we have a foreign key constraint that says, okay, this question has exactly one survey instance, and we're using that multi-part quarter year constraint to associate it with the instance. And then because a survey instance will have questions across multiple constructs, each question is then associated with the construct name. So we have this situation where every response belongs to one specific survey instance, and every question within that response belongs to one construct. And there are multiple constructs within an instance. And then this last table here, post, that's just a leftover from a tutorial. I don't need that. Okay, that's the SQL schema. Let's take a look at a little bit of the Python. Let's turn off Nginx over here. We don't need it. Okay. First off, we're looking at, in my GitHub repo, CS-445 visualization, Flask app DevOps survey, we're looking at upload.py. This provides routes to the Flask app and provides methods to upload those CSV files and to create the survey instances when the CSVs are uploaded. This heading map maps the names of the questions, which the actual questions that are asked, with the short names of the questions. These short names on the right side, these values associated with each key in the dictionary, belong to the questions as they are named in the database. I ended up not actually using the long text of the questions. We only use the short text, so this is a little bit noisier than it needs to be, but at some point I plan to map it backwards so that I could look at the longer names. Likert map here, this just maps the responses strongly agree, neither agree nor disagree, etc. to numbers so that we can do averages and statistics on those responses. This is some Flask boilerplate. We're setting up a blueprint. We're setting up a route. The route's called upCSV for upload CSV. When we post to this endpoint, we take a file object. This is where we saw I uploaded that file that I selected from the disk. We take the file object, we take the quarter, and we take the year. And then we create a name for our survey instance. We look to see if there is an instance of that survey already. If there is, we bail out. If not, we insert a new survey associated with that CSV file that we've just uploaded. Here is some stuff that's dealing with making the directories, saving the files to the disk. There's some safety and sanitization going on for file names. I'm not doing a lot of sanitization or any really for the CSV files, so that's a risk. The idea here is that I know what the input is like, and I don't intend to keep this specific instance of the app running for long, so I'm not too worried about it, but that's something that I'll want to improve if I continue to use this. Okay, down here on line 86 is where we actually take the CSV file and insert it into the database. We call this insert CSV method. Insert CSV maps the field names from the CSV file back to column names in the survey instances table in my database. I do some special value setting for this. I will complete the survey question because that was the only question that was optional in the survey. So if somebody didn't answer it or left it blank, I just say, yeah, I set a default value for it. Strongly disagree. I'm not going to fill it out. again, I don't want to talk about psychometrics, but I intended that to be a practice question to get people into the swing of quickly responding to Likert scale questions. Okay, so I map those headings into column names in my my responses database, and then I insert that into the survey data points. So let's see, it's also doing this mapping with the Likert map, so it takes the strongly agree, strongly disagree, and maps those back to numbers. So it inserts everything, cool, commit it, and then over here, last method, show CSVs. This is just what happens if you click the link to see which CSVs exist. Okay, so the main idea here is that this upload CSV file in Python, it gives us routes to upload CSV files. It will write those files to disk, and then if it's a new survey, it will create a new survey instance, and then it will upload all of the lines or all of the rows from that CSV file into the survey data points table in my SQL database. Okay, then the next thing we're interested in, we have all of this data. It exists in the SQL database. We want to query that data and we want to graph it somehow, right? Okay, so let's do that. This is again Flask, so we have all Flask boilerplate. I've added additional imports for matplotlib. Matplotlib is what's going to do the graphing. We have the headings here. Q headings refers to each of the headings in the questions. Let's see, so our route here, we only have one route for graphs. It's show instance. So when we click on the show instance link in the UI, we go through and we set up a plot. We do some arrangement to make the plot the height and width that we want, to set some keys and some other things. This is where I'm mapping values in each bar in the bar graph to colors. So anything where the score is above 3.8, I arbitrarily consider that to be good. 2.8, 3.8 is okay, and then anything below 2.8 considered to be bad. And I label each of these with those colors. Add some labels to the graph. Down here, this one's kind of neat. We build a byte buffer. We save the figure to the byte buffer. We encode it as base 64 data. We close this. Otherwise, if we don't close this, the matplotlib just holds these graphs around, and it's sort of a memory leak. We don't actually care about the graph existing in memory after we've rendered it and send it back to the web browser anyway. And then we render template with that data, that base 64 data that we added to our buffer. Okay, but to be able to have all of that data that we write into the graph, we need to have some averages. We have some data. This does two things basically. I get a average, or I get all of the rows for a specific survey instance. That's what the select is doing. It's going to do a left join from survey data points to survey instances. It's going to join on quarter and year equal the quarter and year that we specify. And remember, quarter and year are the multi-part key that uniquely identify a specific instance. This query runs twice, and the reason for that, or two really similar queries run twice. It's because I made the SQL database do a count of rows in a specific survey instance, and we use that count for the averages. It would have been smarter and more efficient probably to do a single query, this select down here on starting on line 88, and then count the rows that are returned from that query in Python. But I wanted to kind of show off a little bit of SQL querying here, because there isn't a ton of querying coming out of the database. So I run those queries. I compute some averages down here on line 98. And then I put that in a Python dict, and I return that dict back to the path up here. What did I call the path? Show instance. And then the averages, these averages here are what are used to render the graph. All right, so there's a bunch of other little bits of code here, things like HTML templates, things like database initializers, config readers, stuff like that. That's not super interesting, I don't think, for database, demonstrating how this can read from a database and graph the data, so I've skipped it. If you're interested, you can look in the GitHub repo or ask me a question I can answer. But since that's a little bit convoluted to show in code, I'll demonstrate it once more in the web browser. All right, let's go back to our CSV list. So remember, we have an upload path. So if you look at the browser up here, we see the up CSV path. This associates with that up CSV method where we create the survey instance and upload all of the survey data points once we've got a CSV file associated with the instance. So let's get another one, just show you this once more. That was Q2 2021. One question here is, why do I have to enter the quarter of the year if it's right here in the file name? And that's because I'm kind of anticipating that the file names might not always match quarter year format. Okay. Let's upload that. Oh, okay. I guess I have to actually choose the file. 2021. So we've uploaded it. The new one is here. I named it incorrectly. Oh well. And there's our new graph. Remember when we click on, let's go back to the CSV list. When we click on graph here, it's going to use that show instance route. So let's click on that. We see show instance up here. It selects the specific file name that we want to graph. And then in the back end, it grabs, it does the SQL query to get all of the rows for that specific SQL instance. It averages the scores for each rows, builds a Python dict. It hands the Python dict back to matplotlib, and matplotlib builds this plot and color codes the graphs. Cool. All right, so it works. I'm pretty happy with it. It doesn't do a lot. It doesn't do nearly as much stuff as I was demonstrating in the original instance of the survey. Somebody's at my door. 1 second.
Hello, Joe.
Hi. Thank you.
How are you?
I'm good.
Keep it warm.
Thank you. You have a good night.
Thank you.
Sorry about that. That's my dinner. Looks delicious. Yeah, so I'm doing a really basic bar graph here. My survey used to do trend analysis, so we would look at where individual questions were trending up or trending down quarter over quarter, or where constructs were trending up or down over quarter. I have a really good idea of how I could do that with matplotlib and querying this database with the schema that I've set up. It takes more time than I have available right now. So whether or not I do that really depends on whether or not I want to continue or reuse this methodology for collecting DevOps survey data. All right, well, that's the project. Let me know if you have any questions. Bye.